So what do we do first is we have to create a graph on 100 nodes where everybody has a different BMI. So mainly we have this city and the city has 100 people which we depict as 100 nodes. So to make this graph, first of all we import our package, import network X as annex, and let's save this file. Let's save this file as let's say evolutionary model.py. So we save this file as evolutionary model.py. We import network access annex. Now we have to create a graph on 100 nodes, which we know is very simple. We have already created many graphs. So what we simply need to do is first of all create a graph g equals to annex.graph, and then we have to add 100 nodes here. So we write g dot add nodes from, and this function demands a list here. So what is the list here? Range 1 to 101. So what will this function do? It will add 100 nodes to this graph with the indices being 1, 2, 3, 4 up to 101. This is one way of doing it. We'll soon look at another way of doing the same thing. And next I want to plot this graph and see how does it look like. So as we know, for plotting we need import matplotlib.pyplot as plt, and then we can use our function annex.draw g and then plt.show. I save this file. Let's run it and see. Python evolutionary model.py. And here we can see a graph with 100 nodes. Okay. Let's quickly look at another way of doing the same thing. So you might be already knowing it, I am just repeating it. So here what we have done is we have made a list here and then passed it. What we can do is have a for loop here. So we can do for I in range 1 to 101. What do we do? G dot add node I, and it creates the same output as before. So when we run this file and we do python evolutionary underscore model.py, we get the same graph. Perfect. Next what we want to do is we want to assign some random BMIs to these people. So for assigning random BMIs to these people, what we will do is, okay, so we'll be first before doing that, we want to make a good use of functions here. So whatever we'll be doing, we'll keep writing it everything in functions only. So this particular piece of code g equals to annex.graph to add node I was for creating our graph. So what we do here is we simply pass a function here g equals to create underscore graph, and this entire thing we shift under the function create underscore graph. So we have this function here, define create underscore graph, and what this function does is it creates a graph having 100 nodes and it returns the graph G. And these two statements, annex.drawG and plt.show, we are using it to visualize our graph. So what do we do is we define another function here, define, and then we name this function as visualize, define visualize G. What it does is it will draw our graph and show it. So we pass both of these statements inside this function, and whenever we have to see this graph, we simply call visualize G. So let's run it and see quickly. So we get here the output which we wanted. So till now everything is perfect. So we have a graph having 100 nodes. Next, what we want to do is we want to assign a body mass index to every person here in this graph. So here are 100 people and we want to assign a BMI to every person. So for that again we take the help of a function and we call the function assign BMI and we pass the graph G in this function. So let's write down the body of this function. So we have defined assign underscore BMI and we have our graph G here. How do we assign a BMI? So we know that BMI is going to be a number from 15 to 40. So what we are going to do is for every node in the network, we generate a random number from 15 to 40 and assign that number as the BMI of this node. So since we need a random number, we need the right package random here. So we import our package random here and we come back to our function assign underscore BMI. How do we assign a BMI to a node? So probably you will remember we have used the attributes of the node. We have learned about the attributes of the node. So we are going to make the use of the attributes of the node. So how do we do it? For each in G dot nodes. So we have an iterator which iterates through every node in G. So for each in G dot nodes, what do we do is we add an attribute G dot node each and let's have the name of this attribute as name. So a better option was having a BMI here, but we are using the name of the attribute to be name itself. I have a reason why I am using the attribute name to be name here, which you'll understand as you see more of this code. So every person has here an attribute and the attribute's name is name. So the attribute is name and the value of the attribute is a random number, random integer from 15 to 40. So what I do is random dot randint and it should be from 15 to 40. In addition to an attribute name, I want one more attribute associated with each node here. Can you guess what that attribute is going to be? I told you that we are going to have two types of nodes in this network. So one type of nodes is corresponding to the people in the network and another type of node is corresponding to the social foci. So we'll need to distinguish between these two kinds of nodes. So hence I take an attribute here G dot node each and I name this attribute as type. So G dot node each type equals 2 and these are 100 people. So I name this as I keep the value as person. So for each of these 100 nodes their type is equal to person. So we have assigned a BMI to every node. And let's put this assign BMI function before visualizing the graph and let us run the code and see it now. We run the code and we see it. So but the graph looks like the previous graph only. So every node here has a BMI but we don't see any BMI here. Why? Because currently our nodes are having no labels. So we need to label our nodes and this particular labeling which we want is the BMI. So every node should be labeled with its BMI. Every node should have a number written on it and that number should be the BMI of this node. So how do we do that? After assigning BMIs to these nodes, we want these as labels. So mainly we need a dictionary for all the labels which can be displayed. We want a dictionary here. Let's name this dictionary as labeldict. And to get this dictionary labeldict, we use a function get labels from G. And this is not an implicit function get labels. We need to define this function. So what do? We define this function get underscore labels G. And what this function is going to do, first of all, we create a dictionary. So we have a dictionary here. Let's name it as dict1. And what will add to this dictionary is the label for every node. Hence, for each in g.nodes, what we are going to do is dict 1 and the value in the value for each. So each is the key here. So dict 1 of each. So each is a node here. Dict 1 of each should be equal to what it should be equal to? The BMI of this person, the BMI of each. So how do we access the BMI of each? BMI is our attribute. We do g.node each and our BMI was stored in the attribute named name. And at the end we return our dictionary dict1. So here you see we get a dictionary label dict equals to get underscore labels g, and this dictionary has all the labels. Now to see these labels in our graph, we look at this function visualize g. We go above, we see this function visualize g. So it was having nx.draw g. We need to add a small code here. We want the labels with each node. So we add labels equals to, and what should be the labels equals to? Our dictionary. And what was the dictionary? Label dict. Do you see a problem here? I see a problem here. We are using labels equals to label dict. How does my code know what is label dict? So we need to pass label dict as an argument here. So we pass this label dict as an argument here. And similarly here, while visualizing the graph G, we need to pass label dict here. So I hope that the code is clear to you. So I'll just quickly recap. What did we do is, after assigning the BMI, we created a dictionary. The name of the dictionary is label dict. And what is the value, what is this dictionary carrying is, this dictionary is having one key for each of the nodes in the network, and the value corresponding to that key, corresponding to that node, is the BMI for that node. And then we return this dictionary dict1 and it's collected in label dict. Now we have a dictionary for all the labels in the graph. So to visualize the graph, we pass this label dict, and here while visualizing we have an extra parameter here, labels, which is equal to label dict. So now we execute this code and see our graph. So I execute our code and you see the graph here. So when we look here at this graph, you can see that every node is marked with the label, and the label is actually its BMI. So these are 100 nodes. If you look at the labels for all these nodes, the label, they range from BMI, that is from 15 to 40. And then you can also see that there are two nodes. It is having a label 31 and this is also label 31. So these two nodes, they are having the same BMI. So here we get a graph where we get different people, and every person is labeled with his or her own BMI. Next, what am I interested in? What I want in the graph? Suppose that we want to see this difference in the form of the node size. That is, I want a person having a higher BMI to appear larger as compared to a person who is having a lower BMI. So what do we do for that is, I want to assign a size to every node, and the size of the node should be equal to or proportional to, the size of a node should be proportional to its BMI. So what do we do for that is, I want an array here, and this array consists of the sizes of different node. So I take an array here, node size, and the value of this node size is, to get the value I call a function get underscore size g, and again this function get underscore size we have to define. So we define this function here, define get underscore size g, and what this function should output is an array of the sizes of different nodes, whatever size we want to keep in the graph. I create an array here, let's say array 1, and then for each in g.nodes, so I put an iterator for all the nodes in the graph. For each in g.nodes, what do? We do array 1 dot append, and what do we append in this array? in this array we append the BMI value of that node, and as we know, how do we extract the BMI value of a node is g dot node each, and then we have here name. This gives us the BMI value of each node, and at the end we return array 1. So we get here an array node size which has the size of different nodes. We want to see it in the graph. So to see it in the graph, we first of all pass it in the function visualize. So in the function visualize, we also pass here the array node size, and then when we are visualizing the graph, what I do here is I include a new parameter which says node underscore size. So, and the value for every node is to be extracted from the array node size. And also we need to pass this array here. So let me pass node size here. You can also keep different names like we pass there the argument node size. So here I can actually keep it n size, and at the end I pass here n size. Just doing it this way for the sake of clarity. We can keep the same name for the argument and the parameters, and we can also keep different names. Let's go back, execute this code and see. Let's execute this code, and okay, what we see here is the size of the nodes have changed, but we are not being able to. So you can see here that some nodes are of smaller size, some nodes are of larger size, but still the difference is not very clear. The graph doesn't look very neat. So what I do is I go back to the code, and for each value wherever we are collecting the size here, so for each value what I do, I multiply it by 20. So I scale the value for the size of every node by 20 so that the graph looks cleaner. And then we go back and then we execute this code. So you can see here this looks more beautiful from the previous graph. So you can see here the nodes which are having a high BMI such as 40, they appear in the biggest in size, and the nodes which are having a lower BMI such as 15, they appear smaller in size. So till now we have just created a network on 100 people where every person has a different BMI, and the size of every person is proportional to his or her BMI when we visualize this network. So for the time being, what I want to do is, while visualizing my graph, I'll now remove the labels. So these are the labels which shows the BMI in our graph. I'll remove the labels. So here we say that the node 10, so you can see that the node 10 is having a very high BMI. Node 87, node 13, these are all having very high BMI, and the nodes like 83, 54, 66, these are having smaller BMI.